Hey folks, how's it going? Coming to the quick little breakdown on this quiz that we just took. To some extent, I think we did okay, but I also think that we probably could have done better at points. I did have a video on this, and we did have an activity in class, so we really need to take a moment, and if we're still stuck with this is our time to learn from it, all right? Because this will continue to come up, and it's important that we know how to do this. All right, so I'll take you through the 3 questions as well as the graphing, and we'll go from there. All right, so here we go. Our first question is we need to write the equation of the line that passes through these points in all 3 forms. So I'm going to start by calculating the slope, and everyone was good in doing that. I think our where we disagreed was what the slope actually is. So first I'm going to start with my y's. I'm going to go -5 minus 1, and then I'm going to do 6 minus 3. Equivalently, you could have done 1 minus -5 and 3 minus 6. The most important thing is that the 1 and the 3 are together and the -5 and the 6 are together, because that's how they appear here. In either case, if I did this, what I would get is I would get -6 over 2. If I did this, I would get +6 over -2, and that is equal to +6 over -3, or -6 over +3, which in either case is equal to -2. So just double check that. -5 minus 1, -6. 6 minus 3 is 3. Gets me a -2. -1 turns into a +5 is 6. 3 minus 6 is -3. In either case, a -2. So you need to start with m being equal to -2. If you got this m wrong, I did give you credit going forward as long as the rest of your equations and such made sense. But this was worth a fair number of the total points. Now I'm going to write it in point slope form. I'll show you both forms. So the biggest thing people did is they mixed their x and their y. Remember, point slope form is y minus k equals m x minus h, where hk is the point that is on the line. So what I'm going to do is I'm going to show you the first one. Y minus 1 equals m x minus 3. That goes through 3, 1. And now remember, make that m to a -2. Alternatively, you could have done y plus 5 equals -2 x minus 6. And that is equivalent. Okay? The big thing I saw people doing, major thing people do, is they flip. So they had the things flipped around. And the other thing is with signs. If I did see some people writing plus -3, that's fine. As long as it's mathematically equivalent, I can rock with that. It's totally fine. Now, to get the slope-intercept form, I mean, if you really wanted to solve for the b value, that's fine. Nothing wrong with that. It's mathematically valid. I don't got a problem with it. Alternatively, you could convert using the point slope form. So I'll show you converting with this first one. Okay, I got y minus 1 equals -2 x minus 3. I'll go ahead and distribute, wave check. Y minus 1 equals -2x. Now this was really tough. Okay, a lot of people made that second mistake. They did not do the negative times a negative is a +6. So many people wrote that -6. That was kind of tough to see. And the last step is adding the 1. Y equals -2x plus 7. If you did the other way around, y plus 5 equals -2x minus 6. Okay, you distribute, wave check. Y plus 5 equals -2x plus 12 minus the 5's. Y equals -2x plus 7. So a couple things here. 1, starting in the right form. 2, the correct distribution. And 3, I did see a lot of people actually subtracting the 1 and getting like a 5 rather than adding the 1. So that was also kind of tough to see. Your final answer, though, is y equals -2x plus 7. Lastly, we're going to put it into standard form. So standard form is just taking the x's and the y's, putting them on the same side, and then mitigating or eliminating any fractions. So in this case, all I need to do is I need to take the 2x and move it over. So I get 2x plus y is equal to 7. please put the x before the y. That was something I was picky about on the quiz. Okay, so in this case, here's our answers. You could either have had one of these two for this point slope. Either one's fine or equivalent. But the slope intercept, you have to get this. And the standard, you have to get that. To check my work, I could plug in, I don't know, how about 3, 1? If I plug in 3 here, 3 times negative 2 is negative 6, plus 7 is 1. Now I take negative 6 and 5, or 6 and negative 5. Negative 2 times 6 is negative 12, plus 7 is negative 5. I could do the same thing here. 2 times 3, because 3, 1. 2 times 3 is 6, plus 1 is 7. That works. 2 times 6 is 12, plus negative 5 is also 7. So plugging in the points helps. So if you needed to rewind, go ahead and do that. And in a second, I'm going to do the graphing. All right, so the graphing was pretty hit or miss. This one was a difficult one. And the one thing I didn't see people doing is I didn't see people really trying to see whether their points made sense. The first thing I saw that was kind of troublesome is a lot of people did not interpret the slope correctly. The slope is negative 1/2. That's down 1, right 2. That was tough. We really got to know this. Unfortunately, I love you guys, but I can't go back and hit that again. You got to know that from middle school. If you don't, that's the time we want to work together. Okay, now what I'm going to do is I'm going to graph this one out, okay? So first, I got to remember this. Think about it like this. The graph of an equation is all of the x's and y's, which when plugged in, make both sides equal. Okay, a lot of people did 2, 2. And here's why that's not right. Look, plug in 2. Okay, let's say you thought 2, 2 was a point. Say you put that on your graph. If 2, 2 is a point on the graph, then 2, 2, when I plug it in, should work. Let's take a look. 2 plus 2 is 4. 4 times negative 1/2 is negative 2. So if I plug in x, I get negative 2. But if I plug in y, 2 minus 2 is 0. And 0 is not equal to negative 2. So 2, 2 can't be a point on the line. Doesn't make both sides equal to each other. But take a look. If I plug in negative 2, what's negative 2 plus 2? It's 0, so that's 0. What's 2 minus 2? That's also 0. So that's why I talk about zeroing both sides. Because if you try to get the x that makes this 0 and the y that makes this 0, then you have 0 equals 0, meaning the equation's true, meaning the point has to be on the line. So that's important. That's why I talk about the zeroing, and we really need to understand this because 0 is not first of all, it's not an obvious thing. It took us thousands of years. We were actually solving quadratics potentially before we knew of the existence and really deep understanding of 0. It's not obvious, but it's something that we want to know about because it's an important concept that we're going to keep seeing in this class, the idea of making something 0. All right, so from here you had two options. You could use the slope and go down 1 over 2, down 1 over 2, down 1 over 2, blah, blah, blah. Alternatively, you could have tried to plug in another point. For example, I could have tried 0, 1. I just happen to know that's on the line already. If I do 1 minus 2, I get negative 1. If I do 0 plus 2, I get 2, which when multiplied by 1/2 is negative 1. Those are equal. So 0, 1 has to be on the line because if I plug in 0 for y and 1 for x, I get the same thing on both sides of the equation. All right, and that's an important thing we have to understand. The graph of an equation corresponds with all the x and y's, which when plugged in to the equation, make both sides equal, right? A graph is just a visualization of the solutions of the equation, right? And we know this because look, if I plug in, we already showed this, right? If I plug in 2, 2, it won't make the equation equal. So 2, 2 is not going to be on the line. All right. Second part. Now B, I did foreshadow this. Here's the thing. I saw some good. I saw some stuff we got to work on. The number one thing that caused mistakes, as I predicted, were attempts to convert this into slope-intercept form. If you attempted to do that, sometimes you got it right. All right, I'll take it. Sometimes, a lot of times, people did not get it right. One, the failure to, people added rather than subtracted the 3x. People only hit one thing with the 4. All right, let's take a different strategy. Let's try to do my intercepts, which some people did do. So here's what I recommend when you graph these things. First, set up your 2 intercepts. And it's not always going to be easy, and that's all right. So 0, 0. Okay, so this is my y-intercept because x equals 0. My x-intercept because y equals 0. So if I start with x equals 0, I can cover up the x with my finger because if I plug in 0, this thing is gone. So 4 times what equals 12? 4 times 3 is equal to 12. So 0, 3 makes both sides of the equation equal. So 0, 3 must be on the graph of your equation. Similarly, I'll go ahead, and maybe that's too big of a finger. How about this? That's a little bit better. I'll plug in a 0 for y. And look, I've got 3x equals 12. So what times 3 equals 12? That would be 4. Okay, so 0, 3 has to be on the line because it makes both sides equal to one another. And 4, 0 has to be on the line because it also makes both sides equal to one another. Okay, so you got to convince yourself it's what you got to do. But the whole idea with standard form, as we talked about in class, is that standard form is the easiest when it comes to finding the intercept. So now I'll come in here. I'll connect my points, and this probably is not the best ruler, but it's what I got right now. See how this works out. Cross my fingers. Hey, not bad. You could use whatever you want. I wasn't too picky on the connecting. Now, what did I miss on both sides? This also costs points. Don't forget your arrows. Your arrows have to be there because the graph doesn't stop at the ends. It keeps going forever. All right, so this was not an easy quiz for all, but that is why you got to watch these videos. You got to understand. You got to fill in those gaps because this is not going to go away. It's going to keep coming back. So take this in. You got to try to your best to understand. I recommend you come and see me if you did not like how your thing turned out so we can work on this together. But remember, you can do it. Okay, I believe in you, but you got to believe in yourself. You got to make the most of this. You got to remember that I'm here for you, but I can't drag you to come see me. You got to come see me and fill in those gaps. All right, so I hope you enjoyed this. Again, I encourage you to keep running through it and understanding it. But otherwise, have a wonderful day, and don't forget to love math.